Ahmed Tikiwa. So a bit of a background about me. I actually started off as a graphic designer when I was like 16. Evolved from that to become a software engineer after actually getting a real passion for um, how software engineering works, being able to just create applications, being able to create websites and all of that. And I actually have seen such a great growth in software engineering where it's become this industry that is just taking over the world. I mean, right now they're actually calling it the fourth industrial revolution. So I basically worked for about 5 years for a software developing company that was basically centering around websites and apps. And at that company, I basically did applications for tech companies like Samsung. I did software for companies like Cell-C, GlowCell. Basically, I was creating these back-end systems that enable them to basically be able to do their work. But I did not feel challenged enough. I didn't feel like, you know what, this is exciting. I actually wanted to do more. So I then found out that, hey, app development is actually a possibility. It is something that you can learn and you can just pick up on and be able to, create applications that can, like in my case, I'm very passionate about creating applications that change the world. So it was then that I actually picked up Android, and so I definitely have a Java background. I started off using Java, which is what Rebecca was touching on earlier. So when you actually start learning Android, Java back then was actually the language to use, and you will actually notice that Java is actually quite a lot of code that you need to write in order for you to be able to actually achieve maybe sometimes even just the smallest thing. You need to write a lot of what they call boilerplate code. So I basically, during my app development time, picked up a language called Kotlin. And within this session, I will basically be explaining why Kotlin, where did it come from, why is it important, and how can it actually be beneficial to you as either a budding software engineer or if you're already a software engineer, how it actually can be very useful to you. So where did Kotlin come from? So I will start off with a brief thing. I grew up watching Fresh Prince of Bel-Air, so it's actually one of my favorite shows. So now this is a story all about how my life got twisted upside down, and I'd like to take a minute or maybe a few more to tell you a story about Kotlin. Now, Kotlin was created by a company called JetBrains. How many of you have actually heard of it? A few. So JetBrains is actually one of those companies that has done quite a bit. They are basically big contributors to the software engineering space. Their speciality is very broad. They actually help developers of all sorts, of all different kinds of languages. So they're basically a software company. And they've built quite a number of software in the space. So you'll see there at the top the IntelliJ IDEA, which is actually what Java developers, as well as Kotlin now, so they've actually integrated Kotlin into it. So what IDEs are called, they're basically integrated development environments. So you basically would like to be able to write, like you see there on the bottom there, PHP Storm. So which is actually one of the languages that I used in my software development career. Now, when you want to write PHP applications, you basically need a tool that's going to be able to help you write this software, to be able to write applications. So in my case, you can use PHP to write backend systems. You can use it to write websites. So they basically built this tool that has got everything that you need within there. And if you make a mistake, it'll actually tell you, hey, you're actually making a mistake here. Here's a suggestion, you know. So these tools are basically supposed to help developers become better in their software engineering career and be able to actually build performance worthy applications. So applications that are actually doing well in the market. So they can actually tell you, hey, dude, this particular piece of code here is actually probably going to cause a crash. Or it's going to cause some errors and all of that. So JetBrains has done a lot of homework, and they've basically managed to establish basically a prestige within the software engineering space. So these are the IDEs that they have created. You see that there's PyCharm, WebStorm, Golang for people who write a language called Go. PHP Storm, as I mentioned, ReSharper, Rider, and then, as you can see, the list will go on. So they've even developed all of this in order to help software engineers. So the question now is, why the need for another language? You know, it's something they actually received a lot of criticism about. Like, why would you actually want to actually create a language in the first place? Don't we have enough? And the truth is, maybe we actually do have enough. But what I've come to note is that whenever a need arises, there's always some sort of means that we actually create in order for us to be able to do things better. For instance, JavaScript, for instance, was the thing when it came to using in web applications. Using JavaScript was actually, considered to be, very, very good. Like if you had JavaScript skills, this is awesome. But JavaScript had its limitations. And people felt it was too much. They felt, you know what, I feel like it's a bit slow. We need to be able to do things, do more things with this language. So you found that people created a thing called jQuery, for instance. So it's kind of the same situation as well with regards to iOS. iOS basically had a language which they were using, Objective-C, and they basically realized that, you know what, it's actually not working well for us. We're actually going to create a whole new language altogether called Swift, and that basically made things easier for them. Okay, so with regards to Kotlin, for instance, you actually had a situation where Java was the language that was the dominating one around the world. How many of you actually write Java? Yeah. So as you can see from the hands raised, Java is actually the language that people actually preferred. Java is the language that is seasoned. It's actually been there for a very, very long time. The number of iterations that it's gone through, basic improvements and all of that. And they've also seen that, you know what, we also want to make this language better. They've also made improvements to their language in order for us to actually be able to do our applications better. Even the Android operating system, it depends on Java for it to actually function properly. So basically, you have this language called Java that is well known, that is out there, and that people really love. So it also begs the question, so why would you want to still create another language? So what I mentioned earlier was what is termed boilerplate code. So boilerplate code is essentially a whole lot of code, in most cases, that you need to actually write in order for you to be able to execute certain functions or certain areas of your code that you need to be able to execute, right? You basically end up potentially with millions of lines of code that can be prone to bugs. And that is one major problem. In fact, the creator of Java has actually termed this thing called the billion-dollar mistake. So this billion-dollar mistake is actually null. So Null. And this null thing is actually very, very dangerous. It is something that can ruin your reputation as a software engineer or as a company as a whole, because people basically will lose trust in you. You'll have applications that will just start crashing all over the show, and people will be like, you know what, we don't trust this software, we're going to move elsewhere, we're going to try to use something else. So that is the problem with Java and most other languages, is that you actually, the more code that you write, the more prone you are going to be to having errors in your code. So that was one of the pain points. So JetBrains, as a company, they actually were a bit, I wouldn't want to say selfish, but essentially the reason why they actually created Kotlin in the first place was because it was actually a problem for them. They weren't really thinking about, okay, what the world is currently experiencing. They actually had a problem with their piece of software, which contained millions of lines of Java code. Now, for them, this actually became very difficult to maintain. They started realizing that, you know what, we actually need to be able to scale this properly. We're going to need to do something about this. Otherwise, you're going to run into issues. Again, this ties into reputation. If you are a software company that the world trusts, you don't want the world to then suddenly abandon you because you made very, very poor mistakes, or errors, that you could have avoided in the beginning. So they basically were like, you know what, Java's not working for us. We need to actually find an alternative. So they then decided, okay, cool, we're going to try and look around. So obviously, writing a new language is a huge task. It's not simple to be able to just start one from scratch. There's a lot of work that you need to put into it in order for you to be able to write this language, right? I mean, even if you look at simple speaking languages, for instance, like Afrikaans or English or French, those languages evolved over time. So it's not just something that was created, instantly. And so they were obviously, looking at it intently and trying to see, okay, should we actually follow this approach, And they basically looked at Groovy. They looked at Scala. And with Scala, they actually were like, you know what? It could work, but we have some issues with it. So for one, performance. They were not happy with the performance. They were not happy with how they wanted to actually integrate their piece of software into Scala. They were not confident that it was actually going to be able to fulfill what they actually wanted out of it. And then they felt also that Scala was going to be very slow. So they obviously were like, you know what? We're a company that the world trusts. We're not going to write software that's going to be slow. We actually want this to be the best software. So whatever we're going to write, we want to make sure that it's backed, and it's solid. So that's when they actually decided, you know what, we're actually going to create a whole new language altogether. And people were very skeptic about it. They actually thought these guys were crazy. But JetBrains were like, nope, we're not going to listen to the skeptics. We're actually going to do this because this is important to us. And yes, so they actually started creating this language called Kotlin. And so they created it in 2010, 2011, they created this language. And then it started growing and growing, even despite the skepticism, despite the criticism that they were receiving. They basically had this thing growing. So they had about 9 iterations of Kotlin being released every single year. And all of this was actually in beta. Okay. So until around 2016, 2017, Kotlin was then finally released as version 1. And it was around this time, there's a guy called Jake Wharton. How many of you guys know him? Yeah. So Jake is actually one of the biggest contributors within the Android space. He's written very useful software that we actually use within the Android sphere. And his company was actually integrated into Google. That's how important he is within the software development space. So he actually came across Kotlin. There was buzz around it, and people were actually speaking about Kotlin a lot, wanting to know when this language is actually going to be integrated into Android, if at all it is. Is Google actually considering integrating it into Android? And people were really wanting Kotlin as a first-class language. They wanted Kotlin to actually be the language of choice because they looked at it and like, you know what, this language, it works well for us. Google, why don't you actually implement this? You know, and so this is how the timeline of Google. So basically, in 2008, the Android SDK was officially released. Okay, and when it was released, um, it was backed with Java. So Java was actually the language of choice, or the first class language at the time in 2008. So when you wanted to write Android, you needed to know Java in order for you to be able to write Android applications. And then in 2009, they decided, you know what, we're not just going to limit Android to Java, because we know there are people out there who actually write C, and there are people out there who also write C++. How many of you guys actually write any of those or use any of those? Yeah. Yeah, so C and C++ were officially integrated into Android. And so basically this meant that three languages were catered for within Android. And basically the range or the area that was now covered with this language was now big. It wasn't just Java, it was now three languages. So you could actually do that. But then there was a huge gap. So from 2009 up until 2017, then Google made an announcement at Google I/O that, hey, we're actually going to be supporting Kotlin as an official language. And this actually came with much excitement because even prior to that, so Google actually had some code labs about 2 weeks prior to Google I/O, and they basically had these sessions with people, and people they had a Q&A session, and one of the guys actually asked, hey, so when are you actually going to implement Kotlin into Android? You know, and Google actually had plans to, introduce Kotlin as an official language. It was actually going to be the major announcement at Google I/O in 2017. And they probably felt that, you know what, we're not going to spoil this because this is a big announcement. We're actually going to sidestep this. So they basically said, you know what, we've been watching, what's been going on. We've been watching this language called Kotlin, and yeah, I think it's good. Yeah. We're looking out for it. Not knowing to the person who actually asked the question that no, 2 weeks later we're actually going to be introducing this language as part of Android. So in 2017. The reason why Google decided to accept this language is because of the popularity. So like I said, people were asking about this. Every single person wanted this as a language of choice because of how easy it is to use, how clean it is to use. So they're like, no, we really want this. So Google looked at this popularity, they considered it, and second point is that it was established. So like I said, it had gone from 2010, 2011. JetBrains had spent a lot of time writing, polishing it, fixing whatever bugs and all of that stuff until this language became stable. So in 2017, it officially became version 1.0. And as far as Google's concerned, this is actually an established language that has been going through the processes of from beta to production to a language that's actually ready for consumption. So Google was confident with this. And also, like I said, as I showed you in the previous slide, so JetBrains created all sorts of IDEs, integrated development environments, right? And one of them is called IntelliJ IDEA. And from IntelliJ IDEA, you've got this thing called Android Studio. Okay, so Android Studio is actually based on this framework called IntelliJ. So IntelliJ, which is created by JetBrains. So now you have got this software, Android Studio, which is created by the people who created Kotlin, that has support for Kotlin. So it was a no-brainer to say, hey, so we actually want to integrate this language. We already have Android Studio supporting C and C++. We have Android Studio supporting Java. And JetBrains have said, hey, we're also going to include Kotlin into the IDE as well. So it was a no-brainer to actually say, you know what? I think we should actually adopt this language. So There was also another key point about this, and this is what they call the interop or the interoperability of Java and Kotlin. So they have situations where, like I said, JetBrains had about millions of lines of code that they had written in Java, right? And you would know, like in our case, so I work for Lino, and our software, our app as well, is split. Would also like it to be like 100% Kotlin, but it obviously started off as Java, and so we basically have a split between Kotlin and Java. Now, it is a very dangerous task, a very dangerous exercise to then just convert your code, which you can actually. The IDE supports it. You can just easily convert it, but it's dangerous. You may run into issues. So you have a situation where you can actually write applications that have both Java and Kotlin. You don't have to drop your Java altogether to be able to write applications, which is the beauty of Kotlin, is that it can interop with Java so the two of them can live side by side. You can actually call Java code from Kotlin and Kotlin code from Java. So it's actually a very simple language. So because of the fact that it's a painful exercise to be able to do this conversion, the advice is that any new code that you write it in Kotlin. So old code that you have in Java, keep it in Java, but if you can like slowly convert it to Kotlin, then do so. But any new code, start to write it in Kotlin. There is an issue that you might actually experience because most of you raise your hands for Java. So you will find that as you're writing Kotlin, you kind of have this Java mindset. So it will take time before you actually switch out of that. And I'll show you the different ways in which it can actually become cleaner. So Kotlin over Java. So Kotlin basically is more expressive. So the idea behind it is that, like I said, you can write hundreds of lines of code, lots of lines of code essentially, to be able to perform certain functions. And Kotlin basically is like, nope, we want you guys to be able to write less code and be able to do more. Okay, so that's the beauty of it. The other thing is that it's safe, and this basically ties into that $1 billion mistake that I told you the Java developer had in that. Kotlin basically realizes that you have these things called null pointer exceptions, which are the worst in applications. People do not like them. If it's an Android app, it'll just crash due to the fact that an object is null, and it shouldn't be. Okay, so in this case, Kotlin gives you the ability to actually be able to define objects as nullable, and this makes it a safe language to use because it actually takes that into account for you to be able to use it and have applications that hardly crash. It is functional. And then the other thing as well is that you can, as Rebecca mentioned earlier, you have what are called extension functions. Now, you have a situation where, and I'll explain in detail later, but you essentially have a situation where you maybe have adopted some libraries into your code, but these libraries are always limited. You know, there are certain things that you want out of a library that unfortunately is not actually present. You probably can't even talk to the developers of the library, but you need this thing. You know, you need it to be able to use whatever function that you need. So extension functions is one of the big things within Kotlin that you can actually use, basically extending a function of another class or object. Okay, so now to get into the meat. Okay, so variables in Kotlin. So you have what is called val. Okay, so val is the one type of variable. Okay, and val is essentially immutable. Okay, meaning it cannot change. And the idea is that, or rather, the encouragement from Kotlin is that you actually need to be using val more than var. Okay, so var is the second type of variable. So var is actually mutable, which means it can change. Okay, so here's the situation here. So you've got val name, And then you see there's a colon there, and then string, and then equal to Ahmed. Okay, so basically val there is the type of the variable, okay, meaning that it's not going to change. The name there is the name that I'm giving to the name of the variable, so name, and then the colon and string. So colon there is basically how you define the type of variable. Okay, so you've got different types of variables. In this case, it's going to be a string. Okay, so then you will see there after the equal sign, I'm basically doing what is called an assignment. So I'm assigning the variable name to Ahmed. Okay, so every time I have the word name there spelled like that, it's actually going to represent this. It's actually going to represent my name there. Okay. Okay, and then if, for instance, you decide that, hey, I want name to be something else. So let's say straight after declaring val name string equals Ahmed, and then you say name equals something. You actually cannot do that. And you'll get an error. So in Android Studio, which it'll actually show you like that, val cannot be reassigned because, like I said, it is immutable. It cannot change. Okay. However, you can actually, if you want to be able to change it, for whatever reason it may be, you then change val to var. Okay, so var means it's a variable, meaning it can be changed. It is mutable. And in Android Studio, in fact, in most of the IntelliJ IDEs, if you have a var, so in other words, something that can change, it'll underline it for you. So that's how you can actually see it there. So in this case, my var name can actually be changed. Okay. Okay, so like in this case, I've got val name, which is a string, which is equal to Ahmed. Okay. Then I have a function called something. And then within there, I've created another variable. Okay. And that variable is actually contained. So the scope of the variable is within the function called something. And then I called it local name. And then that local name is also of type string. And then, but I'm also saying local name is equal to name. Okay. And as you can see, val name string equals Ahmed is outside, right? That means that it's a top order variable. Okay. So that state is not contained within anything. You can actually use it anywhere within your code. You can actually call it like that. Okay. So in this case, I'm basically saying that this local name here, I'm giving it the value of the name that's above there. Okay, and this is how you would define it. Okay. Okay, so the other thing as well, like I mentioned there, where when it comes to safety, okay, so like in this case, Kotlin does a check. So is you're actually writing code, and this is the beauty of having IDEs. So IDEs basically help you, like I said, to be able to write good code. Okay, you need an IDE. You can decide to write this using a text editor, but I would not advise that. IDEs basically help you and give you tips. So like in this case, you see here there's a squiggly red line, and this is the error. So if you mouse over with your arrow, you will actually see what the error is in this particular instance. So there I have a val or a variable called name, which is a string, and then I'm not giving it a value anymore. I'm actually saying that it's actually going to be null. Okay, so you actually see there's an error there that says nope, null cannot be a value of a non-null type string. Okay, meaning that string there, it's expecting that string is not going to be null. It's expecting that string is going to have a value. So null is not a value, so it's not accepting that. Okay, so to be able to get past that, you then need to change it. So you can actually have a question mark. So the question mark, as you see there next to the type. Okay, so you always define the type there and then the question mark. So the question mark basically represents that, hey, there are certain instances where name could actually be null. And so Kotlin will basically allow you to have name be null in certain cases, or sometimes it can actually have a value. Okay, so now you don't see a squiggly red line anymore. Now this is correct, because now I'm saying this can be null in certain cases. Okay, and then you'll notice here there's a difference. So val name colon string equals something. And then here I said val name equals Ahmed. As you're seeing, I've omitted the colon string. And this is because of what is called type inference. This is because of what is called type inference within Kotlin, right? So type inference is basically something that Kotlin does in the background. So as you're busy typing, it's already inspecting, it's going through your code and seeing, okay, is Ahmed actually typing the right stuff here in this, okay? So even as you're typing, it will detect, okay, is name being used elsewhere? Is name correct? Or is it spelled correctly? So even if you're using an English word, is it spelled correctly? Okay? So in this case, it's actually noticing that, hey, the name there is being assigned to what is called a string. So a string there, a string literal, as you can see it with quotation marks, okay? This here identifies that this thing here is actually a string. So Kotlin is smart enough to know that name is a string. So there's no need to tell me that it's a string. So there's no need for me to actually say val name colon string, okay? Because Kotlin already knows that, you've already given me a string. I know exactly, okay, that this is a string. There's certain cases where you might need to actually define what the type of variable it is, but there's certain cases where Kotlin will be smart enough to know that this here is actually a string. Okay, then you have what are called if, else, and when statements. Okay, so within a function, for instance, called something, you can then say, okay, so if name is not equal to null, so basically you're doing a check there to see if name is not null, okay? Then I'm going to show a toast. So in Android, it's basically like a pop-up message. So toast, make text context, and then within the name there, so I'm using that name variable there, and then I'm going to show the toast. And then in the case where maybe name is actually null, so then it will go into the else section. And then the else section is what is then going to be executed. So in this case, I'm saying if the name is going to be null, then I'm rather going to give it a name called John, for instance. Yes, I'm not changing my name to John, but I'm just saying. So in this case, you will give it the name John, and then you will actually show that. Okay. Okay, so there's a separate thing. So in Java, you might be familiar with what are called switch statements. Okay, so a switch statement is basically one that takes an argument. Okay, so you basically say switch. Let's say if the value of something is fits a certain criteria, then I want you to do A, B, and C. Okay, so in this case, this is the Kotlin version of a switch statement, which is called a when. Okay, and as you can see, it's actually much more cleaner than a switch statement. So in that case there where it says name, when the name is not null, then I want you to show a toast, okay, and then this will be executed. Okay? However, in the case when it is null, so you can have what is called an else block within a when statement. So else, then show John as the name there. Okay, so that's how. So you can actually have as many when statements as when conditions as you want. Okay, within the when statement. Okay, and then you have what are called if, else, and when expressions. Okay, so here it's a bit different. Okay, so in this case, I'm saying val local name needs to be executed or defined as the value of this statement here. Okay, so I can actually say if the name is not equal to null, then use the name. So in other words, local name will be equal to name. So it will then evaluate this section. And then, or it will come to this else here and say, no, I found that the name is actually null, so I'm going to use John. So local name is equal to John if name is null, or local name is equal to name, and so forth. Okay? And then the toast will use local name as the variable there. Okay? And then you can have this as well in a when expression. So here I've got local name. Also similar to how I was doing it with the if expression. So val local name is equal to when the name is not null, then use the name. Else, use John. Okay. And then one of the funny things within Kotlin is I guess certain namings for certain things. So in this case, the Elvis operator, and it has got nothing to do with Elvis's dance or singing, but actually his hair. Okay. Yes, his hair. Okay, so you actually see that the quaff of his hair there, the top there, is actually question mark colon. So this actually represents what is called an Elvis operator. And an Elvis operator is basically used to do checks. Okay. So in this case, val local name is equal to name, and then Elvis operator, which is a question mark colon, and then John. Okay, so here I'm saying name, if the name is not null, then it's going to use name. If the name is null, then it's going to use John. Okay. As you can see, it's much cleaner. So this is the whole point of Kotlin, in that you're meant to be able to write less code, okay, but be able to do more. Okay. Okay. Functions. This is how you define a function. Okay. A function, and I guess maybe this was probably a nice stab from Kotlin to say Kotlin is actually fun. So in Java, you actually have public void and then the name of the function. So in this case, to define a function is just fun. That's the keyword. And then my function name is something with the brackets there. And then here the colon, basically to say this is going to return something. So every function in Kotlin returns something. It always returns an object, in this case, unit. Okay, so that's how you define function. Okay, and then in my case now you notice that I omitted unit because by default it will actually return unit, so I don't need to define it. Okay, so in this case I have function show string, okay, and then function show string returns a string, okay, and then it's going to return hello Kotlin everywhere as a string there, okay. Now, like I said, Kotlin is smart enough to know that, hey, the return of this is actually a string, okay, so you can actually omit certain things, so, and actually make it cleaner, and as you can see, it's now one line. It's gone from 2 lines to 1 line. Okay, so show string returns a string which is equal to Kotlin everywhere, and this is what is called expressive syntax within Kotlin. Okay, and then one step further. So now you see I've removed string, and now it includes just that. Fun show string equals hello Kotlin everywhere. Okay, function arguments. Okay, so function arguments essentially, you basically would like to maybe make your functions dynamic. Okay, so my function arguments there, so I've got one called event name. And then in Kotlin, this is how you define it. You have the name of the argument and the type. Okay, so event name is the argument name, and then the type is string. And then my function is going to return a string, and then it's going to go there, return hello plus event name. But you then see a squiggly line underneath there, and then that's the IDE saying, you know what? You actually can make this cleaner, okay? So you can actually convert the concatenation. So in Java, there's a common thing where you use the plus sign to concatenate, and it's saying you can convert this concatenation into a template, and to actually again going making your code look neat. So in this case, hello, and then the dollar sign, and then event name. So no plus sign to in order for you to join things. You can actually just write it like that, which is again clean. Okay, you've also got a situation here where you can actually write it as a single line. Okay, show string event name equals hello event name. Okay, so you have a situation where show error message. So in this case, I have 2 variables, 2 arguments, which are error, which is of type string, and length, which is of type int, and then I'm giving it a default value called toast.lengthLong. So all I just need to do is toast, and then there that function is going to return a toast message. Okay, and then all I just need to do is when I call the function show error message, I then just say this is the error. So I didn't have to pass in the length. As you can see there, all I had to do was do error and length, and then that's it. And this is how I can call it. Or I can redefine the second parameter and say length short. Okay. So Kotlin is basically one of those languages that, when you use it, you're actually going to find that it is such a breeze to use. You find yourself writing less and less code. One of the things as well, like in Java, you have a semicolon, for you to be able to separate your lines. That's gone. You don't need to use that. The idea is they want you to be able to write less code. Okay, so you will see how beautiful this language is as you use it more and more. It is actually very fun to use, and I hope you use it on a daily basis. And that's me. Thank you.